Now let's consider situations where compounding occurs more frequently than annual compounding. And specifically, we'll be looking at semi-annual compounding, quarterly compounding, monthly, and then even daily. I'll have a small discussion on continuous compounding, but it's not commonly used. Semi-annual compounding is typically used for bonds and bond payments in the form of coupon payments. Banks are most frequently used quarterly compounding, especially on savings accounts and payment accounts. Monthly compounding occurs for different types of consumer loans and investments, such as certificates of deposits. And there are some bonds that might use monthly compounding, and it's very common with leases. Daily compounding is probably the most common when there's an interest-bearing account or the consumer is paying an interest to some institution like a bank. Your credit card is most likely based on a daily compounded rate. And as I said, continuous compounding could be used, but it's not very common, especially because of fair lending laws. The consumer has to understand the nature of the compounding period, and it's difficult to explain how continuous compounding works to the average consumer. So let's take a look at an example that we'll use we'll revisit several different times, where we take $100 invested for 2 years at 8%, and we want to find what is the future value of that amount, assuming these different compounding periods. So some interest rate terms that we'll be using. Simple interest rate, this is often what people quote as your interest rate for a loan in the bank accounts and credit cards and bonds. It is also called the nominal rate or the quoted rate. Commonly heard it called, and we'll call it in this class, the APR or annual percentage rate, although that term can be misused by some banks. In the example above, the simple or quoted rate will be 8%. That's the annual rate, assuming that it's compounded annually. When we look at semi-annual compounding, we'll say that it is an 8% APR or 8% simple rate, but compounded semi-annually. The periodic rate is the rate that you'll receive over the compounding period. So the periodic rate is the simple or APR divided by M. M is the number of compounding periods per year. So in the example above, if it were annual, M would equal 1. If it were semi-annual, M would equal 2. Got ahead of myself, sorry. So in the above example, the periodic rate, the annual would be 8%. The semi-annual would be 8% divided by 2, or 4% per period. So let's first start by keying in the inputs for the annual. We need to, as before, clear time value of money. And we want to make sure, at least at this time, that the payments per year is set at 1. We'll look at a case where we can change that in a moment. So our situation says that we have 2 years, and this is annual, so we have 2 compounding periods at 8% per period. We will be investing $100 into an account, and we compute the future value at $116.64. We have 2 years of simple interest, and then we have 8% of the interest received the first period, and that's that extra 64 cents that you see tacked on there. That's the effect of compounding. Now let's move to the semi-annual case. So you'll notice now that we still have the same time period, 2 years, but we're going to break that time period into 4 compounding periods. So the first 6 months, the next 6 months, 18 months, and then finally 24 months. So the simple rate, or the periodic rate, will be divided by, we'll calculate the periodic rate by dividing the simple rate by 2. So let's start over again. We're going to clear time value of money. I know that P/Y is set at 1, so I'm going to skip that step. Now, n in this case is the number of compounding periods. We have 2 years, but we have 2 compounding periods per year, so that gives us 4 compounding periods. And we have a simple rate of 8% divided by 2, which means that we'll get a 4% interest rate per compounding period, or per 6 months. Everything else is the same, $100 invested. And we compute the future value. Now what we notice here is in the previous problem, it was $116.64. Now we see the effect of earlier and more frequent compounding. There's an extra 37 cents there collected because of the effect of this frequency in the compounding. Now we can use these payment per year functions. It does not change the number of periods. We still have to calculate the number of semi-annual periods, but we would, in this case, put in a simple or annual rate. And what the p/y function does is it changes that simple rate of 8% into an effective rate given the compounding period. So we'll clear time value of money, and in this case we will change p/y to 2. Make sure you hit enter. Second, clear or quit. Now we'll still enter the 4 compounding periods, or the 4 6-month periods, but now we will only enter a simple 8%. $100 invested, and we compute the future value, and we get the same result as we did when we were assuming that the interest rate was the periodic rate. So that's what the p/y function does for us. Now, word of warning. You must be very careful when you use the p/y function in the BA2 Plus calculator, because even if you were to clear everything, clear time value of money, clear work, do everything else, the p/y function will still be left at whatever you set it the previous time. So you must be very careful that you go in each time and reset it back to 1 in order to continue on with the next problem. So the next problem is just a continuation where we look at quarterly compounding. Now we see that there are 4 compounding periods per year for a total of 8 compounding periods. So I'm going to clear time value of money and put in 8 compounding periods. My periodic rate is 8% divided by 4 compounding periods per year, or 2% per compounding period. So 2% is entered in as the interest rate, and we put in the same $100 investment and calculate the future value. We can see now with quarterly, we've gone from semi-annually to quarterly, and the change in doubling the number of compounding periods is 17 cents. It's not as much as the 34 cents or 37 cents we got in the first example, but it is still a higher value. So we can see that the effects of frequency and compounding kind of have this diminishing returns, meaning that you're getting, more interest, but you're getting a smaller change each time you double the number of compounding periods or triple the number of compounding periods. All right, we'll end there and finish up this section, finishing up with this problem using the monthly, and then we'll move at the annuities in the next segment.